Welcome everybody. So I'm just going to give you an outline of what's going to be happening today, so we know where we are. The first thing to say though is that the entire meeting is being recorded. So when it does come to questions or debate, please can you just be mindful of what you're saying. Please be aware, you are live, please do not swear, that kind of thing, okay? So I guess we can edit some things out, but it would be best if we didn't have to be editing out, okay? Okay, that's a note to myself as well. So, okay, yes. Okay, so we have four speakers who are going to form a panel. So firstly, those speakers will give us about 15 minutes introduction to various aspects around 4 per mil. There will be a couple of minutes after each talk just for questions around points for clarification. And then after those 4 talks, then we get into our debate. Abad Chabi is going to chair that debate for us, and the debate will also then be prompted with video clips that we took during the Soil Organic Matter meeting in September. So we have some questions that Abad's been primed with just to get the debate going, but we really want to hear from each and every one of you. So I think we have about an hour and a half for that debate. Then we also have poster presentations, which are back in the room, I think, where we had refreshments. We've then got our annual meeting for the Society, and then at more refreshments and posters after that. At 5:30, we have our networking reception and posters. Okay, so I hope that everybody can stay with us right through the whole day, and particularly right through for the drinks reception at the end. I think that's all I need to say, but Jack has a question for you.
It's supposed to be interactive and a debate, so I thought before you actually had the presentations from our 4 speakers, is actually get a sense in the room, so this is about the 4 per mil initiative, whether you think that it's achievable in the UK or not. So hands up who thinks it's achievable in the UK. A smattering, less than 10. Who thinks no? A few more, probably 20. And who doesn't know? The rest of you sitting on the fence. Okay, so hopefully by the end, we're going to ask the same question at the end of the debate, just to see whether there's any movement in those 3 categories or not. So what we're going to do now is Liz is going to chair the next session for the 4 speakers.
So firstly, our first speaker is Claire Chenu, and Claire's going to talk to us, provide us some scene-setting information and an overview of the 4 per mil initiative.
So good afternoon. So it's a pleasure to be here, and thank you very much to Liz and to the British Soil Science Society for inviting me for this debate. So I am working in AgroParisTech, so it's a technical university close to Paris, in Grignon, and I'm a soil organic matter, some organic carbon scientist, and I'm involved in the 4 per mil initiative as a member and vice president of the scientific and technical committee of the initiative. So what I would like to do is set the scene, present you the initiative, and what are the scientific foundations, and of course come with it the challenges in terms of science. So what is it? You know about it, I think. It's a political initiative that started at the COP21 based on 2 points. First, that nationally determined contributions of the Paris Agreement were not enough to meet the 2 degrees target. Here is the trend in greenhouse gas emissions globally with applying the national determined contributions of the Paris Agreement, and this is the trajectory that should lead to 2 degrees limitation. So there's a gap. There's a gap to meet, so there's need to find ways to partly at least compensate this gap. And another point was the recognition at the COP21. It was even much larger at the COP23 very recently in Bonn of the role of agriculture in climate change and in climate change negotiations. So it was a political initiative that was signed, so a declaration was signed by a series of countries' representatives, of the FAO, signed it, and a series of NGOs, groups. And what did they sign? They signed a general commitment to do what was in their capacity to increase soil organic matter and promote carbon sequestration, soil carbon sequestration, through the application of appropriate farming and forestry practices in order to contribute to food security. It's first climate change mitigation and adaptation to climate change. So 3 objectives. So that's what they committed to. Now, this number, the 4 per million number, where does it come from? It comes from a very global estimate that was made by colleagues a while ago, simply comparing the amount of carbon that lies and is stored in soil, 2,400 gigatons of carbon worldwide, with the annual emissions of carbon as CO2 from fossil fuels, and remarking that the proportion was extremely low. So in theory, increasing these stocks by 4 per mil could compensate global stocks. Now, what is really important, there has been lots of debate regarding that, is that, the main idea is that soils have a potential, extremely important role in climate change mitigation. Very small changes of soil carbon could partly offset our emissions. Very small changes in terms of losing carbon could partially increase greenhouse gas emissions very rapidly. And what is important is that it is an aspirational goal. It is not a normative one. Well, what was really brilliant in a sense with that is that this number presented to a Minister of Agriculture who had some agricultural background, he made tilt in his head, so that was brought his attention and brought the attention to politicians. But definitely it is not a normative target. The goal is to maintain or increase soil organic carbon stocks. So the question you had, is it achievable? Is it achievable to maintain or increase soil organic carbon stocks? This is not a goal. So this is extremely important. There has been, for some evolution on that. Now, how does it work? So it's an initiative that is a multi-partner initiative, an action plan. An action plan is carbon sequestering operational project. The idea is to promote such projects, to provide the background to help such projects in different countries with very varied stakeholders, and a research program. And actually, it is more defining research priorities, trying to promote consultation, collaboration among different bodies worldwide about promoting research. And so these 2 outputs come from a forum of partners. These are those who signed the initiatives, some who committed them more, that they signed that they agreed with the organization, and these are non-profit, so the companies cannot be part of the decision body, and there's a scientific and technical committee, the scientific body, and an executive secretariat. So this whole person works with these 2 expected outputs, carbon sequestering operational projects and research initiatives, research priorities, research consultation. Who's in there right now? This is the last numbers that were presented at the COP23 in Bonn. There are these nearly 300 signatories of the Paris Declaration, including countries, international organizations, foundations, development banks, NGOs, research bodies and universities, farmers' organizations, and enterprises. One example was that Danone signed at the COP23. And consortium members, so these are a subset, and in particular companies cannot be among consortium members. And Chair is the president of the NEPAD, South African organization, and Stéphane Le Foll is the vice president. I will come back to the activities of the 4 per mil later in my talk. Now, I wanted to present the scientific challenges and define a few terms and see what are the limits and then the challenges of this initiative. So I will talk about carbon stocks. And one point that is quite important, I would like to talk about carbon storage and sequestration, because these 2 terms are used often the same way, and they do not mean the same thing. You may know that soil organic carbon, in soil organic matter, the residence times of molecules containing carbon and of carbon atoms is not the same. And one simple way, this is very simple, to divide residence time is to consider that the fraction of soil organic carbon is labile, has rapid turnover rate, so low mean residence time. A higher fraction is the slow pool, and another one is the stable pool that has residence time up to centuries. Okay, you implement practices, agroforestry, for example, to increase soil organic carbon stocks. Two possibilities in terms of pools. You might do that. Practices may result in that you increase the labile pool, but you do not increase the amount of carbon that is stored with very long residence times. Or it may be that you increase the carbon that is stored with low residence time, but not the labile pool. These are not the same. So here there is storage, here there is storage and sequestration. Sequestration is the process of transferring CO2 from the atmosphere into soil for a given land unit, plants, plant residues, organic residues, which are retained in the soils for a long time. So here you have storage, but here you have sequestration. You have increased the amount of carbon that is stored for a long time. Does it matter? Yes. This is the most interesting in terms of carbon sequestration. This may be the most interesting in terms of soil fertility. And the 4 initiative addresses the two. Well, we had quite lively debates in our scientific and technical committee because some of us were saying, well, we're not only interested in that. And others said this. So I think this is to be considered. And the message I wanted to convey is I think we should be careful with the use of these two terms. Another term I would like to come is that sequestration means that it's a net uptake from the atmosphere, but I will come back to that. Now, how much for how long? What is possible? So again, let's imagine a situation where you have carbon stocks, you implement a practice, there's an increase of carbon up to a new equilibrium. Storage is extremely slow. So this is obviously a limit in terms of monitoring, verification. It is also a limit in terms of public policies to sustain that. The cap, for example. Well, you might not be interested much more in the cap, I'm sorry. And storage is limited. So soils cannot be used forever to compensate for our way of living. But again, the idea is not to use soils to avoid us from making any efforts. It is a complementary way to go through the 2 degrees target. So the closer, this figure means that the closer you are from the equilibrium, the less carbon sequestration potential you have. Storage is reversible. If you stop the practice, for example, it was cover crops, you stop with cover crops, you're going to go back to the previous equilibrium. And there are soil degradation situations, changes in land use, which can lead to very rapid and huge carbon losses. So it is slow, it is reversible, so you have to maintain the practices. That's a very strong limit. And you cannot go increasing forever. And also, if you implement a different management option, the equilibrium value might not be the same, which makes things more complicated. And the storage potential of a soil can be defined as the maximum gain of carbon, so total carbon. I'm not discussing here with a long-term stabilization, that is reachable for a given timeline under a given land use and a given management. And it depends on climate and soil type. And here come one of the largest scientific questions. Where is this target? What are the values of these different equilibriums? And is there a physical limit to carbon storage in soils? Is there a finite capacity of carbon stabilization due to the nature and abundance of minerals? You may have heard of this idea that soil carbon may become saturated. That doesn't mean that you cannot load more carbon in soil. Peat is there to show the opposite. But that might be a certain limit for carbon to be stabilized for decades or centuries in soils. So it's more for the sequestration side than for the storage side. So this is a huge ongoing research question. It's interesting also, could there be tools derived from that? So these are intrinsic limits of carbon storage and sequestration. And now what I would like to do is, what is possible? Well, is it possible to store more carbon in agricultural soils? And my answer is yes, there are different levers to increase primary production through cover crops, covering bare soil with, for example, with grass in vineyards, or it can be in orchards as well. Temporary grassland, increasing the length of grassland in temporary grasslands, agroforestry. Here we increase primary production, so the inputs to soil, cancelling fires, playing on the exports, so crop residue return to soil, and importing exogenous organic matter from the cattle or cattle residues or urban residues. So all this increases the input of carbon to soil. Now, there are other levers on this side to reduce erosion with no tillage and conservation agriculture, also with agroforestry, with hedges, also with cover crops, and to some extent to reduce biodegradation rates and mineralization rates by reducing tillage. Although this lever has been shown recently, I don't know if others are going to talk about it, to be much less important than we thought. So most of the levers are on this side, increasing carbon inputs to soil. So a variety of practices allow, in theory, to increase soil organic carbon stocks. Now, is it feasible to achieve this magic number, which I just said it's not an objective, but still, I think what is interesting with this number is that it is not a normative objective. It should not be used as such, but after all, for us scientists, it's a good question. Can we quantify the ability of soils to store carbon to a certain level? What is possible? And here I presented you, these are results from an assessment that was done in France recently regarding practices able to reduce greenhouse gas emissions from agriculture. And here I plotted the additional carbon storage in tons of carbon per hectare and per year for a series of practices. No tillage is here, very low rates. And we have in our cropped soils, we have an average 50 tons of carbon per hectare soils. So 50 multiplied by 4 divided by 1,000 gives you 0.2 tons per carbon and per hectare and per year. So, yeah, not always, but yes, some practices. If you use this number locally, yes, it's meaningful for some practices, not for all of them. Now, nationally, while using this same set, in this assessment where we simulated, but very, very roughly, we're doing it now better, but very roughly, the application of these practices, the ones that are presented here, adding all these stocks for the surface area of mainland France led to an amount that was circa 20% of natural greenhouse gas emissions from agriculture. And greenhouse gas emissions in France from agriculture are roughly 1/4 of total greenhouse gas emissions. So using this very extremely simple caricatural simulation, we are very far from compensating our national emissions. So yeah, locally, this number could be used. Nationally, I doubt. And globally, there has been, there's many papers going out in the literature about the technical potential of applying agricultural practices to store more carbon in soils. And examples are papers from Smith et al. About 1 gigaton of carbon per year, and a recent paper by Sommer et al. You see, more or less in the same range. Again, if we would apply ratio, considering, for example, in surface soils, there's more or less 800 gigatons of carbon worldwide, multiplied by 4, divided by 1,000, it's 4.2 gigatons of carbon. So it's less, definitely less. So yes, this number is not achievable. Now, it is not a normative target. We were discussing, I think it was David Hopkins, and I think his example was great, was saying that we have the same thing in France, that you should eat at least 5 fruits and vegetables per day. Okay, and I guess you agree that 3 is better than 2, and 4 is better than 3, and 5 is better than 5. If you do 6, it's better. Well, we are, I think, we should put in the same logic. So it's not, the idea is to protect existing carbon stocks and improve. So is it achievable now? There are demands in terms of nutrients, water, biomass. that may locally limit the ability to implement practices that store carbon and may limit the ability to increase carbon stocks, and these have been documented in the literature recently. And for example, for biomass, I think a big question is the use of biomass, because there are other uses of biomass to feed the cattle, or even for domestic use that may be much more important for for the farmers than improving the carbon content of soils. So there's clearly limits that rely on the use of resources. And also, yes, to store more carbon, you need to have soil. So artificialization, urbanization is a strong limit. One point to be careful about is that does it lead to a positive greenhouse gas balance? Not necessarily. In many cases, yes, but not necessarily, and one has to be cautious about N2 emissions. Methane emissions, for example, increasing carbon contents in rice paddies might not lead to a positive balance in terms of greenhouse gas emissions, and there are questions with leakage and displacement. Let's take one example. Have compost here. Applying it equally to dividing the amount of compost I have equally into 2 plots will store a certain amount of carbon. Applying it differentially, all the compost here in this plot and none in plot B might lead here. The organic carbon stocks will be increased, but not at this scale. At the scale of the farm, there will be no change. So regarding the application of organic manure, of residues from animals, most of them are already applied to soils, at least in all countries in Europe. So there's not much to gain. What has to be thought, I think, is where it is more advisable to place them, if it's possible to transport them. But there's not much to gain. They're already brought back to soils. It's not the same with urban vastas. There's a huge potential there, a huge potential in terms of carbon, but also nitrogen, phosphorus, etc. And also questions in terms of benefits are, does it improve yield stability, production? Yes, but if you go to the literature, it's not that easy to find relationships between soil organic matter content and yields if you account for fertilization with mineral fertilizers. So this is clearly also an area where syntheses are needed and more research probably are needed to quantify the advantages of organic matter. Okay, so there's lots of questions for research, and this led the Scientific and Technical Committee of the initiative to propose research priorities that are estimating the potential of carbon sequestration and associated benefits and drawbacks, developing practices adapted to specific soil and climate conditions, so here more the agronomy and the social aspects, economical also, defining and strengthening the enabling environment, regulation, markets, monitoring, reporting, and verification of soil carbon, in as much as changes are slow, difficult, and costly to measure. And just to give you a hint, for example, for the first point, you can see that there are issues about mapping soil carbon, carbon sequestration, technical potential, biophysical and chemical conditions, nitrogen, phosphorus, water, vulnerability of organic carbon stocks, duration of the carbon sequestration, non-CO2 greenhouse gas emissions, effects on yields, ecosystem goods and services, and effects on adaptation. So there's a lot. I think this initiative, for me, one of its virtues is to ask questions to the scientific community, questions that could be transferred into implementation. So another activity of the 4PM initiative is to promote operational projects that aim at protecting soil organic carbon stocks that have less losses as usual, as business as usual, or improving soil organic carbon stocks. And for that, the idea is that the Scientific and Technical Committee will perform a formative assessment for the project holders that are interested in. So formative assessment is to help project holders to have better projects. So that maybe they can go after to financiers and have chances to be financed or not. Well, and what we define is a sequential way to do it, with first step is safeguard criteria, direct reference criteria, indirect ones, and cross-cutting criteria. We decided to put this evaluation in the framework of the Sustainable Development Goals that apply, we think, to all activity domains for human societies. So what is it? Safeguard criteria. Ensure that the project will not compromise human rights, land rights, and poverty alleviation. carbon farming and expropriation of family farmers is not acceptable. Direct reference criteria refer to carbon stocks, land degradation neutrality, climate change adaptation, climate change mitigation, no more greenhouse gas emissions than business as usual, and food security. Indirect reference criteria to welfare and well-being, biodiversity and ecosystem services, water and nutrient cycles, not deteriorating water quality, for example, in terms of nitrate, in terms of pesticides, and cross-cutting criteria refer to developing participatory and socially inclusive approaches. So the idea is that, like in the assessment, projects will be considered first for this and will go through only if they meet all of these criteria. Then for the second step, soil carbon has to be plus. What means plus? Less carbon loss than business as usual, or more carbon stored. So no quantitative objective, but do better as business as usual. And hence, the idea is to provide a narrative advice aimed at improving the quality of the project before implementation and during implementation. And we are working on criteria, so I will not develop on this, but for each category to define, and the idea is not to reinvent the wheel. Use, for example, the IPCC Tier 1, 2, 3 methods. So to conclude, I'd like to say, so the goal of the initiative is definitely to maintain or increase soil organic carbon stocks. So it's not a matter of magic numbers. The concepts are much more important than the numbers. There are many benefits: climate mitigation, climate adaptation, food security, but also biodiversity, ecosystem services. It is achievable locally. So what I mean is achievable locally to decrease losses or to improve stocks. And there's knowledge in-house. The scientific community, the practitioners have already lots of knowledge. But there are very specific and important scientific questions like potential kinetics. It has a cost in terms of nutrient, water, biomass practices. This needs to be evaluated. These are also questions addressed to the scientific community. It comprises risks. And a full greenhouse gas balance needs to be made. And it's, luckily, one initiative among others. And maybe the virtue was to stimulate also other bodies to have their own initiative. For example, the future special report of IPCC on land, the FAO is extremely active, has a cookbook for soil carbon measure, organized a symposium, is organizing a manual for carbon sequestration, the Global Research Alliance, the UNCCD, so fighting against desertification, even discussions on the CAP, implement that. And the advantage, I think, is to put soil carbon in a wider perspective than just soil carbon, nitrogen, water. And it's a major opportunity to raise soils higher in the political agenda and in public awareness. And for this, I think that it already has been a success. And I think that it is a challenge for the soil science community. We have a unique opportunity for our science to be used for implementation, to be used by practitioners, maybe to be used by public bodies for regulation, for incentives. So it's a challenge. Do we work to provide the necessary knowledge? I think we should. And I would like to thank you for your attention, and I'm looking forward to discussion.
Thank you very much, Claire. That was a great start to the day. So we've got time for